Today, let's look at the resolution of two or more vectors. So let's consider a system, and this is a system that is being affected or disturbed by three vectors, or let's say three forces. So watch out. We have this system, and we will see it as having cardinal point. That's a cardinal point. Here is the north. Here is the what? East, here is the south, and here is the what? The west. And this system that is in question is affected by three forces. Let's say this is the first force that is affecting it, and it is inclined to an angle of theta 1. Is that clear? And let's say this is the what? Second force that is affecting it, and it is inclined to the horizontal to an angle of theta 1, 2. And this is the what? Third force that is affecting it, and it is also inclined to the horizontal to an angle of theta 3. Now they'll ask you, what is the resultant force or acting on this system? Now we have the forces that are affecting this system. They are force 1, force 2, and force 3. So I have force 1, the force 2, and the force 3. Now their angle of inclination is what? Theta. So F1 is inclined to the horizontal at an angle of theta 1. F2 is inclined to the horizontal at an angle of theta 2. F3 is inclined to the horizontal at an angle of theta 3. So go and watch my video under resolution of a single vector. I did that video. Or do you know what? I will put the link. I'll drop the link in the comment section. So click on it, watch that video. You see where we got that if the angle of inclination is to the horizontal, that the horizontal component of the force is actually F cos theta by the formula. So, and if it is inclined to the horizontal as well, that the vertical component of the force is given by F sine what? Theta. But a situation whereby the angle is to the vertical, that's the angle of inclination, that's this theta 1 now, it is no longer touching the horizontal axis. When it is touching the what? This vertical axis, the formula will change. I derived it in that video. Please endeavor to watch it. The horizontal component of the force will now be F sine what? Theta. Now the same thing, if the angle of inclination is now to the vertical, that it is touching this north and south, the vertical component of the force will be F cos theta. Is that clear? So this means that we are going to resolve these forces in the horizontal direction and vertical direction, that we have to get the horizontal component of the force and what the vertical component of the force. So let's see, here is the what? The horizontal what? Component, and here is the what? The vertical component. We have to resolve these forces, and that's what we are doing with solution of two or more forces, two or more vectors. So resolving F1 to the horizontal direction. Now, remember that this is just like a graph. If it's a graph, we said that this is positive y-axis, and here is negative y-axis, and this side is positive x-axis, and here is what? Negative x-axis. Is that clear? Now imagine a situation whereby I want to resolve F1 to the horizontal, right? I want to resolve F1 to the horizontal. It means that I'm going to trace down. So if I trace down, I'm meeting the horizontal axis, right? So, and I know the angle is to the horizontal. So we are taking the formula F cos theta, right? Now it means that F1 will now be plus F1 cos theta 1 plus F1 cos what? Theta 1. It is plus reason. If you trace this, because you are going to the horizontal, so you have to take the F1 to the horizontal axis. So where did you meet? Plus, right? So it will be plus F1 cos theta 1. Remember, we are taking these two formulas. Reason, because these angles of inclination that are touching the what? The horizontal axis. Look at them. That are touching the, had it been, or if in a situation that are touching the vertical axis, the formula we will take this one. Is that clear? So what if I resolve F1 to the vertical axis? Now, if I trace this F1 to the vertical axis, that's to this y axis, where did I meet again? Plus y, right? So I'm meeting plus y. So to the vertical axis, that's y axis, right? So the formula will now be plus F1 what? Sine theta 1. That's to the vertical axis, you'll be taking this. To the horizontal axis, you'll be taking this. So it is plus again. Reason, if you trace it, you have to meet plus. So I have that F2 now. If you watch F2, let's resolve it to the horizontal axis. No, we are taking this formula. So I have, if you trace this thing to the horizontal axis, we are meeting negative x. So it will be minus F2 cos what? Theta 2. Now, if you resolve it to the vertical, you are taking it to the vertical. So you're having it is plus y. So it is plus what? F1, F2 I mean, plus we are now here for 2. F2 what? Sine theta 2. Is that clear? Now if it is F3, we have to resort to the horizontal. So if we take it to the horizontal axis, what are we having? Minus, right? So I have minus F3 cos theta 3. Is that clear? But F3, the same F3 now, if we take it to the what? Vertical axis, that resolving to the vertical, we have a minus y. So it will be what? Minus F3 sine what? Theta 3. So this is the way to resolve what? Vectors. Two or more what? Vectors. Trying to find their resultant. So now after doing this, you must get the total, that the summation of the what? The horizontal, that the resolution to the horizontal component, that summation of fs. So the answer for this case will be f1 cos theta 1, because you know this will give you a value. F1, they will give you the force now. They will give you theta, the angle. So you have to get a value. So you have to add everything. So in this case, it will be this plus this plus this. So it is F1 cos theta 1 plus minus F2 cos theta 2 plus what? Minus F3 cos what? Theta 3. Is that clear? The summation of Fy will be what? The same thing. You have to get plus what? F1 sine what? Theta 1 plus F2 sine what? Theta 2 plus minus what? F3 what? Sine theta 3. After you must have done this, then the answer you get, whether minus or plus, determine how you get your result, and in this case. So this is the way to resolve what? Vectors in the horizontal and vertical components. I hope it's clear. Have a nice day. Like, comment, share, and follow Courses Academy. Bye bye.